Yeah, so welcome everyone. Thanks for coming. So it's not a lecture or just a brief talk or tutorial that introduce how to use the printer that we have at the lab, so it can help on your research or help on your project in the future. So the three parts. The first part is the 3D printing basic concept, and then the second part will try to design and print a small piece. Then some other resources will be introduced at the end. So currently there are tons of different types of 3D printings, but you see this here has 10 types of 3D printing technology. If you go through, the one we mainly use, or we mainly focus on, is fused deposition modeling. So the idea is really simple. You just not this one here. This picture actually explains the whole procedure. Use a material, basically kind of plastic filaments, and then melt that and push that on the platform. That's kind of the very basic idea, and that's actually our two different type of two printers all use this technology. There are some other advanced technology like this one. They basically use laser to cure the specific material and make it solid. So that's another one, but it's more expensive, more dangerous to use. So yeah, this is the one. And the one we use is like this one, basically just melt the plastic and put on the top of each other and make the solid result. So this is the one we'll mainly discussed, and this is the machine that we have. But if we go to, but even with this FDM 3D printing technology, there are actually tons of devices. So there are three types here. The red one actually we used is this one, like this one, the red one, but it has some issues. It always failed in the middle of the printing, so it's not so usable at this moment. The one we'll discuss today is Delta FDM printer, like that one. So you see the difference, and this is the Delta. It will move in this way, up and down, and move in this way. This one is just up, down, X, Y. And there's some Polar one, basically the same idea, but use this platform on this one here. And the last one will be the 3D robotic arm. Basically, just use the robotic arm to do the printing. It works in a different way as well. So we will mainly focus on the Delta one. It's more stable. It requires less calibration. It's more usable, more easy for students to use. So we'll mainly discuss this one. And when we discuss, actually, if any more interested in this, let's see. There are tons of printers you can purchase. In the future, if anyone interested, you can check this website, this link. So the best for this one is one of the recommend is the Ultimaker 3. Actually, this is, you don't require, so there are two types. You can buy the kit, you assemble by yourself, then make it the day or week, depends on your knowledge, or your patience. And another one is the whole set. You just buy and you use it. Just the one calibration, use it, the whole set. So this is a whole set. It's more expensive, but it's really good. And the similar one is this one. This has the whole set or has the kit. It's really much cheaper. You see, it's like 20% price of that one. It's give a pretty good, pretty quality, and you can, if you can buy it by yourself. You can play the 3D printing. It's also, this is an open community, so you can ask questions, post questions, and you can fix most of the problems, improve the printing qualities by yourself. But for this one, you have to pay $1,000 to do one update or one fix, to fix some issues. That happens to the other printer as well. So it's really expensive. This is more affordable, but the quality is really good. For the Delta one, actually, I think this is really good one. Also, it's really expensive, but that one is DIY kit that I spent like a day or two to assemble by myself from the scratch. So when you receive that, it's just a flat box with all the small pieces. You have to put them together step by step. So yeah, there's always a kit set session you can buy directly, but it's more expensive, but it's reliable. But once it has issues, you have to pay lots of money to fix that. Another option is the DIY kit. It's much cheaper, much affordable. But when you run into the issues, you have to search and fix by yourself. Normally, there are online forums you can get help from. So I think this is FDM printer types, the purchase options. And also the material, oh, sorry. So you see all these, let's see here. All these printers need the material, filaments, to do the printing. And there are tons of different filaments you can, sorry, where's the, here. Tons of different filaments that you can purchase and you can use for different purpose. And the most common affordable one is PLA. So I think for our research project, normally it's totally okay. It's solid, it's cheap, it can run long term as well. And the color just color. There's no specific purpose for that. Another one is ABS. You need the Lego that we use this kind of material. It's much more solid, but require higher temperature to melt that and use that. And it has a stink smell, so it's not good for the health as well. So you have to be careful. It's not so bad, but you have to be careful, and it's more a little bit expensive and hard to work on. So the PLA is currently the best option for us. So I normally use this to do the printing. It works pretty well for us. And another one I want to briefly mention is the this one. Nylon is you can actually put the color easily on top of that, like the clothes. And this one, flexible TPE, TPU, or TPC, doesn't matter. You can consider it as a flexible PLA. Basically, you can, like a rubber filling. So it can squeeze, right? Some pieces for our project may require this squeeze plastic piece that you can actually put on it. For example, some pieces that we may need to print is like a bunch of cable. We want to squeeze them together, right? We can print this squeezed tube that can squeeze them together. That actually works pretty well. That's the most common way to use that, I think. So these are three most important PLA, ABS, and flexible, say PLA or TPU, TPE, this kind of pretty materials. So the one that we got is the PLA.
So does our printer support all of those?
PLA and ABS support, but for the flexible material, the material has to be really close to the printer hand, because if our machine currently has a really long cable,
right,
and if you do the printing, the flexible is too big, so it cannot print precisely. So currently it does not support, but we can modify that to make it happen. So yeah, that's the material that we need to use. So that's all the hardware. Once we get the 3D printer, we get the filament. Next step is to use the software to design the shape, the piece that you want to use. So normally we'll use the CAD software, like for example, the most popular one. Let me open this one. Let's close all this. This is most popular one. It's really it's free, and it's really user friendly. You see the demo here. You just change the shape, combine them together, cut. See that you got. It's really straightforward. I think you can learn it in an hour, and you can print it whatever you want. But for the more advanced one, that you can use this one, but I think you need pay the fees for the subscription here. It's more advanced, industry oriented, so you can do more complicated one. It's more more feature inside, like you can do a really complicated one. So that's the software. So you guys can go through this. This is a really expensive one, but it's really powerful. This is cheap, free. This is free, user-friendly, but you can do very basic task. Another one that I'm using right now when I try to learn by myself is this one, but it's stopped. So it's pretty sad, but you can still download that. And personally, I feel much easy to use. So this is the one. I'll show a quick demo later, and we can decide that. So once you get the 3D model, and for example, we just really quick to do this. We got this one. This is the 3D CAD design, and you want to export into a 3D file for printing. And normally, the most common one that we want to use is STL. So lots of software actually support this. And if you export to STL, say, desktop, test print. Yeah, it's desktop. Okay. So this is the file. Let's delete these two that I used for the test. So this is STL file. Actually, there are lots of software you can open and see how it looks like. But here, we'll skip that. We'll directly do the slicing. So what is slicing? So you see, we got a solid cube here. But how could we let the 3D printer know how to print that, right? How do we convert this cube, this 3D model, into a machine code that the printer can do the printing? So we normally use the slicer. We named this slicer, basically cut slide by slide, line by line. So actually there's a introduction explanation about the slicer software. 34. So you guys can also check this link. Let me see. 34. Oh, here. So the slicing software prepares the 3D model for you for your 3D printer. Slice the 3D model into the same horizontal layers that 3D printer can interpret and print, basically the machine code, right? So different slicing software has different algorithms. They have different qualities for the final printing, right? So it's not the same. So there are tons of slicers. And here, we will normally use, there are two options that we can easily use inside the lab. The first is the Simplify 3D. This is the paid software. It's run really good, really well. Have great user interface. Actually, the lab purchased for almost $200. It's a really good one. Currently, it's the top one that we can use at this moment. For example, if we load, let's say, but you have to use on this laptop. So that will be placed next to the slicer, and we configure the slicing software for the printer that I already done for this printer and that printer. Then we just prepare to print. And you can see if you zoom in, the cube will be converted to these lines step by step. You will see how it will be printed, right? That's how it looks like. I'll explain more details when we do the live tutorial. But that's how it looks like. When you save, you will get the G code. G code is the machine code for the 3D printing, all the 3D printers. So you got the STL file exported from the CAD software, and then you put this STL file into the slicing software, and you export that, slicing them, and export that as a G code. Then you copy the G code into the machine and run it. That's how it works. 2 steps.
So I noticed you didn't recommend SketchUp at all. Nobody's using SketchUp anymore?
You can.
Okay.
But normally it's for architecture. It's more large scale. Of course, you still can do that. There's no big difference.
It exports STL.
Yes, any STL can be done, can be used. Another is a free software named Repeater, I think. repeat tire. Yeah, I'll open this. But this one, I didn't configure that. So we already, I think for the MakerBot, we already have this software. Where is it? This one. But you have to configure the profile for your printers. I didn't use that because we already have the much better software here, so I didn't put any effort on that. So, but anyone interested actually can work on that as well. So this is the, this is software. Similar idea. You just drag this into that, and the slicer you can choose. There are tons of different slicers you see here. The Simplify 3D has its own, which works much better. It's basically algorithm that convert this. Say you slice. I think this is default one. So you have to configure different printers. So if you see similar idea, you see, so change range, it'll start printing. You see it looks not so good compared to the one that we have because we didn't configure that yet. So same idea, you can use both, but currently at the lab, this is the best one. This is already paid by the lab, so I encourage to use this, save lots of time and energy on that.
So is that similar to the MakerBot software, like, because that's what creates its own SG code?
Yes, same idea. So yeah.
Principle, just not proprietary.
Yes, yeah, you're right.
And for different slicer algorithms, you have to download the DLL and then like you can choose different slicers, right?
Well, for this open software, you see actually the provides several slicing algorithms that or engine they normally say. So you see the Cura engine, Slice 3D, 3R, Skin Reforge. So you can choose that. But some software, especially the commercial software, they just already built in their slicing algorithm into that. So there's no other options. So when you click, you see when you click prepare to print, this is the same slicing, like the slicing button that we have on the other open software. So open source or the free software, you can choose different slicing algorithm. But for these commercial, normally just one built-in. Yeah.
But for these options, to have these options, they're there by default, or do you have to put in?
Some of the default, like these are default. If you want to add more, some software like this one they support. But the problem is that you still have to configure the slicing software by yourself for your printer. That happens to every different types of printers. So you got a new printer, you have to configure your slicing software. And that's how. I'll show you how to configure the configure part. Okay, now we run into the, I think that's all the basic information, hardware, software. Now we'll try to print small one, step by step. I already designed and print this user manual. I think some people already read this. This is some piece that we already printed. Let's see how it looks like. The printer that we have is this one. It's free shipped from Alibaba and has a big community, online community. So you can actually update by yourself. You can fix lots of problems by yourself without asking others. So I basically searched by myself. I think anyone else can just, if you're interested, you can also build your own. So this is the printer that we have here. So they actually directly shipped from China, Alibaba, and currently it's really popular one for this big Delta printing machine. Okay, we'll use this step by step, see how we print the sample piece. So I think maybe 10 minutes.
So you're using the Simplify 3D software?
Yeah. So for example, you create, like this software, you normally just create a basic shape, then you do the editing on top of that. For example, I can extrude the surface. And if you want to be more precise, you can actually do the number as well. And let's see. I'll do a really quick change. And you can also change the shape like the lines, like this way. And also the curved one. Like this. And we'll put another cube to make a, not this one. So you can move. So there's X, Y, Z movement, horizontal. And also the rotation. Okay, there's no rotation on this, but yeah, basically select X, Y, Z, and you do the select object. Then move step by step. So something like this. And also you can, of course, you can change the size. Right, this is too big for us, so let me just quickly change. I think that's all. And of course, there are tons of other options. Another important thing is this one. So I'll combine or subtract. So what we try to do is to move this here. This ruler, you just so different software has different ways to do that. You can learn that really quick. It's not very complicated software usage. This is basically aligned with this, and we see what's the size of it. You can see it's 1010, so we just move a little bit. I say 5, 15, and move another 5. That's it. So the most useful function here is the merge. You combine two together, or you subtract, like this, how it looks like. So you click the object that you want to subtract and click the shape that you want to remove, and then this will be shadowed, and then you click stop. Now you have yeah, that's great. Okay, and you can also change this to this way view to more precise way, and perspective way. You can got this. So the next step, I'll quickly show this one. Let's make it small enough to put on top that we merge them together. You can also squeeze that directly and put it like, say 10. You're done, and then you put the ruler here, and you click object. So just align that. I don't know what this is. Okay. Okay, it's too small. It's each side, so we just move it up. Don't make so don't print. I'll talk later. So let's see here. We basically finished this one. You can just drag a little bit here, a little bit here. So that's a shape that we want to print at the end. What we need to do is another step, combine or merge this together. So now it's a solid piece. You would not. It's not good to print separately. Otherwise, there will extra layer between these two that are not attached together well. So you have to merge them all pieces together. That's how it looks like. I will try to print it out. And what you need to do, export STL. Of course, if you want to combine them by the end, you can also click this one. So export, same test to print 2.
Is it like necessary to check that ASCII thing? Like do you know what that sort of changes? And when you make a convert to STL, it says something about this ASCII.
Here, like this one?
Export to ASCII.
Not really, but it's more compatible for other softwares. So just in case, yeah, it's no big difference in general. Okay. It's just more compatible to others. So we got the piece, and it looks really ugly, but whatever. let's just drag this into the slicing software. You can see it's popped out here. Yeah. And sometimes if, like, for example, if you move around and you realize the best way is to print in the middle, of course. And because when we do the calibration, the middle is the most precise position. And what to do that, and when you move around, there's tons of options. You can move it back, like center array the model. It's back. And if you sometimes you lift a little bit on the Z, like say here. Yeah. I don't know how to. Here, like 10. Or sometimes you made the model, but you don't know there's a gap between this model or the pretty platform. What you can do is, I'll normally use is to drop the model to the table. It will drop there. So that's how. When you do the editing, you want to rotate sometimes. You just double click, and there's tons of options. So the position, this is translation, rotation, and scaling. So you can do whatever you want. For example, we try to rotate on the Z, so say 90 degree. So you can work in this way. So that's how it works. There are tons of other options you can do. So now the most important step is to choose the profile, slicing profile for your printer. Already labeled two printers, table 1, table 2. So you have to choose specific profile for each printers. So you see here there's table 1, so we have to choose table 1. Right? This profile includes all the calibration file, all the printing files. So you cannot use table 2's profile to do the printing on table 1 because it does not match. The calibration, all this will shift. Right? It's all calibrate. So for the calibration itself, let's let's finish this first. So we choose high resolution. It's basically more refined details, more fine detail. And for the medium, it's just average detail, but it's enough. If you want to do high resolution, that will take double times or more, and don't overstat. For all most of our research project, it does not require that high quality, unless you want to do a final print for your demo or for your, final project submission, something like that. You can do a really high quality resolution. So we choose medium. Another one, if you want some piece require really solid, it may take lots force. So you may want to go to 100%. It's fully solid. Right? This infill, basically, you see there are some holes when do the printing. It does not print every every space, all the space inside the model. It just prints some framework that can support this surface. That's it. Normally we will go 30%. It's a really good deal. There's a really good number, and yeah, if you want to go higher, that will take much longer time and consume more filaments. So that's honestly, in most cases, just not necessary to do that. If you want to do really solid piece and get lots of force on that, you can go 100%. So this is all the configurations. So the layers, basically, if you run into some troubles, you try to change the configuration here. Most of them, like 70 or 80%, are default or common. What you need to do to adjust for different printers is like the rest 20 or 30% of parameters. So I won't go into deep inside, but like the diameters is like for this printer it's 0.4 millimeter, and sometimes we print skin. Another thing that I want to mention is that you could include the raft, basically extra layers for the bottom to make sure you have really flat, solid bottom. But our printer, Delta printer, actually does not require that. We already have really it doesn't move, the bottom doesn't move, so we don't need that. And also, we have a heat band, so the bottom will heat up. It's pretty warm, so make the flat really the bottom layer really secured, attached to the bottom, and also really flat, right? So we don't need that. this is a rough, so we don't use that. But for the other printer, normally we have to use that. Otherwise, it's just not work. Yeah. And also the generator support. So some people, some students actually at the beginning they try to print this L shape. They just put design in this way. They just put in slicer. One issue is that the printing will do this way, and there's no support. So there's no way to print in the middle of the air, right? So what you need to do is to create click this one. Oh, sorry. Click generator support, which means that they will print extra materials here at the same time. That can be easily removed once the printing is finished, right? So you have to remember this. Try to avoid this shape or this kind of mid-air printing. Why? Because it's really difficult to do this. And if you this support, it's have a bigger chance to fail in the middle of the way, right? It's not, and consume tons of extra material. Why don't you print in this way? Right, you just print this way and print this way. There's no extra support. Yes, it's much easier to print.
Or size.
Yeah, you can also like do this way at the same time. So you just try to, there's the tons of tips, but it depends on the piece that you want to print. And also try to remember, this FDM printer cannot print really small scale. Like say you really tiny dot, you try to print it out. There's no way, because normally it's like, as you see, it's 0.4 millimeter. There's no way to do a really precise small piece. It's not, otherwise if it can print, it's not precise and it's not solid, strong enough to attach to the main body. So try to remember that.
We shouldn't change that parameter either, right? Because that is a 0.4 millimeter nozzle.
No.
So you don't want to change that? Or?
No, you don't. Yeah, for this printer, that's a fixed number. Yeah. So yeah. So see if another thing that for the lab purpose, if you change anything and you want to keep it, try to save as new. Say test printer print. Don't update or overwrite the original default one that I built. Otherwise, it will mess up other people's printing. Okay, remember, if you want to, now you see you have your own, if you want to keep it, right? Or you can remove it as well. So you just click this one, you remove your own. Once you're done, you don't need that. But these four are default, don't change it. If you click this, you see it will modify it. And some people will say update, right? Then overwrite, no one will know what you have done to this profile for this printer. What you need to do is just keep it what it looks like. If you want to keep your own, just save as new, right? Write your name, maybe like say Huidong, and you know that's your profile, right?
Do we have the original somewhere?
I already, what we can do is export FF file. So you can export like this one here. You choose export FF profile.
That's for the printer profile.
Yes, for the printer profile. You can.
Are those saved somewhere?
Not really. I think, yes. So I think, yeah, I can do that and share it to everyone.
Oh, back up.
So you can do at next time. I already saved that. So next time you can just, you can just load. If you lost or someone just changed and you figure out there's something wrong with that, you can just load that directly from somewhere else. So that's how it looks like. And yeah, so the most important thing is that choose the correct printer profile for your printer. So here we'll choose one, and we don't need roughed in most cases. And here for this printer, there's no mid-air hanging around piece, so we will skip the support. So now we click the prepare to print. Basically, all these steps are included in the menu. Prepare to print. You see, now you have the result already. This part really important and necessary because this will do the initial printing, and normally when you start printing, the bed will heat up first, and the nozzle will heat up second after that. When the nozzle reach 100, like say 90 degrees, the filament will slowly come out. And that's the part that you don't want to use or you don't want to have on your print. So this piece will do the printing first to remove that part, right? Make sure everything is going smooth. Once you finish this one, the skirt, then we'll start to do the printing. So you see, normally you can check how it looks like, what the printing will looks like in the middle of the way. It's really important to observe some problems in the middle of the printing. Say sometimes you will see, oh, there's a mid-air printing, right? Or it's too small to print, you cannot see the difference. So this, you see, this is how it looks like. And you're done the printing. And the next steps to begin the printing over USB, which is not recommended because sometimes the computer is stuck, it will freeze the printer as well. The best way is just save to the SD card and start the printing. And here is some basic information. It will take almost 1 hour. It will take this length of filaments and cost, something like that. So we just save that to the, let's say, and try to put all these files, in the folder to make sure you don't create lots of messy files on the desktop. Say STL file, just put all this stuff here. I don't know why I have to refresh. This is a G code, just put here. And later you can check it if you want to. So I think that's all. But first thing first, safety is the most important thing here. You are dealing with like the heat bed is around 60 to 80 degree. Our setup, I think it's 60. I think it's temperature. Yeah, so this is 60. And for the extruder, it's almost 200 degree. So try really careful when you do the printing, right? Really careful. And try to use this. If you see some extra filaments attached on the nozzle, you just use this to peel it off. Don't use your hand. Don't use your hand, okay? Once you've done the printing, the bed is still, the bed will cooling down, but before it's totally cooling down, just to rip it off, say like 15 degrees, 16 or 15 degrees, you just wait cooling a little bit, make the printing result solid enough, you'll peel it off. At that moment, if the temperature is still like above 40 degrees, it's really easy to peel it off. Use your hand. Don't use any tools. It will scratch the heat bed easily, and next printing will be really messy. Okay, so
that's a really big problem with 3D printers is people go in with some sort of tool.
Oh yeah.
And it just really ruins the bed. So you have to be very careful.
So I think this is the turn off from here. And SD card you can pop out from the display. And actually, this machine is really good. So they have a SD card slot. We just pop in, and we copy this one. So put everything inside this. Let me delete this one. This is all my test. Did I delete this? So then we can start printing. I think that's all. Well, so I think all the steps actually with the screenshot already described in the profile. You just choose a profile and do the printing. You see on the right side is the heat bed temperature. It will reach to 60. Currently it's 23. And on the left is a nozzle temperature that will reach to almost 200. Currently it's 0. It's not 0, but this is the time that consumed. This is the progress percentage. And if you run into any trouble that you want to cancel that, just do the operation on the right side and you click stop. That's it. And also,
this is written in the manual.
Yes, yeah. So that's. We'll see how it looks like. And also another thing that I want to mention is that some people will knock the machine after they use, or if you move to another place, the calibration is really precise. reach to millimeter accuracy. If you move the printer, or if you sometimes knock the arm, then next people come. That happens several times. Then people come and say, it does not even touch the heat bed at the beginning. Then what you need to do is do the calibration. It's all automatically. They also described in the menu. Just click system calibration and wait for 10 minutes and it's done. You don't need to do anything. You just click the button. That's it. Yeah.
So it like measures it itself.
Yeah, measure by itself. It will take 5 minutes in total, but just wait. It'll heat up and wait. Basically, 10 minutes. It's all done. So you don't need to do any extra. That happens several times. Just pretty.
It might be a good idea to do if you haven't used the printer for a while. Maybe.
Yes, yeah. That's what I did. Yeah, yes, yeah. That's what I did.
Otherwise, you waste it.
Yes, you're right. So.
I used it last, and if I got in there with a tool, messed it up.
Yeah. So there are some, when the printing starts, there's some extra materials if anyone want to go deep further. So this 101 for the 3D printing actually covered most of the talk that I discussed, and that's good material resource. And some YouTubers actually did really good tutorial as well. That's I learned most of my 3D printing knowledge from. So for example, this one give you some very deep. I think they have also have the 101 lesson. Like you see ABS basics, PLA basics, filament's choice. There are tons of also the machine. Sorry, just let it pretty. Yeah, so it's tons of things, software, hardware, materials. So it actually gives lots of in-depth review, and that's really good. There are a few really popular ones that you can go through. Also, this printer has actually fairly big, active Facebook group you can join if you run into any trouble. People share lots of message, pictures, videos, informations, and if you run any trouble or you want to improve your printers, you can also do that as well.
So I just noticed that some of the extrusion just came out and dropped onto the bed.
I try to remove that.
This is get rid of it.
Yeah. Normally, first layer, it's better to stay there and wait. Yeah. Make sure everything goes well. Once the first layer prints successfully, normally there's no other issues. So at the first layer printing, I normally wait there with these tools. I try to peel off the dropped filament, right? So,
it'll be probably fine.
Yeah. So you see, actually, the skirt is pretty messy, but it doesn't matter. That's not what we want. The inner piece is really smooth. That's enough. Yeah, some extra I should remove that, but that's not. That's okay. Oh. And don't use your hand like what I did. Just try to use this one to peel it off easily. So because the heat bed is really warm, it's really easy to peel that. You won't destroy your model. And once it's done, remember the nozzle will still like 200 degrees. That will take at least 10 minutes to cooling that down. Try to not touch it. Try to warn other people's. So this printing is just done. Try to not use that. And also the heat bed it's hot, but it does not burn the people. But try not to touch it as well. So safety is the first priority here anyway. So I think that's all contact. We'll see once we finish. We'll see how it looks like. Currently we got the new filaments. It works pretty well with the printers. And there's another machine that you can also use. You can try to print. You can follow the menus. You can search. I send out the email with all these contacts. You can also follow that as well for more details. So any question you can also ask me, or you can search on the website. Normally, you ask me, I'll search, then reply you. So that's how it looks like.
And what happens if we wanted to change filament?
Oh, that's a good question. So there's one. There's one bar that you can push, but the first step is to heat it up. you try to print something, but you hit up and start to printing, you just pause, and stop.
Yep.
Then you can just pull this bar and drag it out. Next time you just, there's a small bar, this one, you can just pull. And the next time you want to, run out this row of the filaments and you want to get a new one, you just add this one and open this and there's a hole you can just screw down and it will go through all the tube into this one. And try to heat up anyway because that will melt and blend into the nozzle successfully. You will see the filaments drop out. That means you are successful. So that's how it looks like. Yeah.
So is the puller mechanism, is that what's at the top?
Yes, yeah. So this one.
Yeah, I see.
So this is a motor that basically drag these filaments into this tube and then it will push into the nozzle. Then it will heat up and melt and then do the pretty. So that it looks like. Yeah. There are tons of other printers. Actually, I really want to mention is this one.
I think it's like a design flaw with the MakerBot software because the gear mechanism is so close to the extrusion nozzle.
Yes.
And then, like if it's having problems, the plastic's already melted and the teeth just start wearing at it and then it just becomes stuck.
Yeah. Well, it depends. That also has its advantage that you can print the flexible PLA. Because flexible, there's a really short distance, you can just directly print. For us, we can't, but actually, initially, this machine was if you buy that, their design is flying extruder. So this one actually hanging by the plastic on top of this. It's already flying around. It's not stable and gives lots of vibration and the result will shaky. So I just install here. Some people do this. But if you really want to do that, you can also print your 3D case on top of this and put this here, then you can do this flexible PLA as well. So you can, this is all configurable, so you can do whatever you want. So yeah, in the future, maybe in the future, I think this one, this is the same stuff that we have. The new one here, I think this SLA, stereo light groove. So this is, basically it's use laser to cure some materials and make it solid. And it can print middle air structure, right? So it's merge everything into the liquid. But it's really dangerous to use this liquid. Harmful to the, yes, really high resolution. It's used later to see. Yeah, so you see how it looks like. But this liquid is really, it takes tons of money to do that. You have to cure that, you have tons of steps, but if anyone interested, you can go through and check this. But it's really expensive, really dangerous to use. It's not, I don't think that's a good option for the lab, since lots of people, so it has some extra steps, lots of materials to use, actually 3 materials. Yeah.
The other thing is mechanical engineering have a bunch of other things. They have a bunch of different 3D printers, laser cutters, and things like that. So this lab is not designed to be a full-featured fab.
There's a big 3D printing lab just downstairs in the engineering core. If anyone interested, actually, I think you can ask their help. They definitely love to help you out of it if you really need some very specific piece that can be printed. So.
They've got a guide dedicated to looking after the whole system and everything.
Yes. So the last one I mentioned in the email several times, if you run into any trouble or you have your own printer, you run into some issues, you can go to this Simplify 3D website and they have the support section. So there are 2 quick guides. One is a printing quality guide, one is material guide. So this is a pretty guide that I run into lots of issues. I think current machines still have this issue. I tried to solve that, but it doesn't give the, doesn't fail the printing, but gives some extra strings. So that's fairly okay. Sometimes some design does not have this issue. So if you have that, just remove that and use the heat blower, hair dryer, to blow that, because really thin, it melts really quick, and you cannot see anything. But it does not destroy the print itself. So that's another good solution. But I still try not to. The other issues actually at the first beginning all run into this, like this, it's all soft. So this is good place to get some help. Another is printing. So you see this flexible filament. So tons of different, that basically gives some ideas what kind of scenario that you need to use per course. Yeah, so configuration that you need to pay attention. And this is software that I used. It has to be stopped, it's discontinued, but you still can download from here. So when I start to use that, it's still available. So I get used to that. It fits my needs, so I keep using that. But the other software I linked also can be used. So I think that's all. Safety first.